Okay, picture this. It's 2008. A mysterious person, or maybe a group, nobody knows, calling themselves Satoshi Nakamoto, drops a 9-page paper online. And this wasn't just some academic paper. Nope, this was a blueprint for a totally new kind of money. Let's dive into exactly what made this white paper so revolutionary and how it proposed a solution to a problem that's basically as old as the internet itself.
I mean, really think about that for a second. When you hand someone a $20 bill, that's it. It's yours, and then boom, it's theirs. There's no middleman, no bank, nothing. But online, it's never, ever been that simple. Every single digital payment has to go through some kind of trusted third party, like a bank or a credit card company. And the Bitcoin Whitepaper starts by asking, why?
So, to really get Satoshi's brilliant solution, we're going to walk through the paper, piece by piece. We'll start with that core problem of trust, then get into the really tricky technical challenges, and finally unpack the absolutely elegant system that was designed to beat them.
Right. So the heart of the issue, the real crux of it, is our complete and total reliance on financial institutions. The paper points out that basically all commerce on the internet forces us to trust these middlemen to process every single transaction we make. And, well, that trust comes with some pretty serious baggage.
This slide just lays it out so clearly. On the left, you've got what Satoshi called the inherent weaknesses of the trust-based model. Transactions can be reversed, which leads to arguments and fraud. The costs are high, so forget about tiny payments. And merchants have to hoover up all our personal data, just in case. The paper's big question was, what if we could build a system based on pure cryptographic proof instead of trust?
So you might be wondering, why couldn't we just email money files to each other before? Well, that brings us to the main villain of our story. This is the single biggest problem that for decades stopped anyone from creating true peer-to-peer digital cash.
See, unlike a physical coin, which can only be in one pocket at one time, a digital file is just information. It can be copied 1,000,000 times perfectly. So if I send you a digital dollar, what's to stop me from copy-pasting that exact same file and sending it to someone else too? That's the double spending problem. And until 2008, the only solution anyone had was a central authority, like a bank, keeping a master list of who owns what.
This is where Satoshi's solution starts to get really clever. It begins by completely redefining what a digital coin even is. It's not a file, it's a history. And this is the first massive piece of the puzzle.
So get this. A coin is defined as the entire chain of its past owners. Each time it's spent, the owner digitally signs it over to the next person, creating a new link in the chain. It's like every coin has its own passport, with a new stamp for every trip it takes. This creates a verifiable history, but it still doesn't totally solve that double spending problem by itself.
And here it is. This is the huge conceptual leap. To stop double spending without a central bank, the paper says that everyone needs to know about every transaction. We need one single shared public history of everything that's ever happened in the order it happened. A universal ledger.
Okay, but a public history is only useful if you can't just, go back and edit it, right? How do you stop someone from rewriting the past to steal back money they already spent? This is where the most ingenious, most mind-blowing part of the white paper comes in.
Satoshi proposed something called proof of work. And you can think of it like this. It's like sealing each page of our public history book into a block of digital concrete. It's really easy for anyone to see that the concrete is there, but it is incredibly difficult and requires a ton of energy to break it open and change what's inside. This was the masterstroke. It was the first time something purely digital was made provably hard to create, tying the digital world to real-world work and energy.
And this just spells out the beauty of the security model. Because if you wanted to change an old block, you'd have to redo its super hard puzzle, plus the puzzles for all the blocks that came after it. Good luck with that. So the rule is simple. The longest chain is the one everyone trusts, because it's the one with the most computational work, the most energy poured into it. It's a system of one CPU, one vote.
So we've got the theory down, but how does this thing actually run in the real world? Who are all these computers solving these hard puzzles? And, a more important question, why would they even bother? The answer is all in the network's brilliant, elegant design.
The paper just lays out this incredibly simple 6-step dance. It's what it calls a system of unstructured simplicity. Transactions get broadcast out to everyone. The computers or nodes gather them up and race to solve the puzzle for that new block. Whoever wins shouts it from the rooftops. Everyone else checks their work, and then the race starts all over again, building on top of the last block. It just works.
But what's the incentive? Why do the work? Well, here it is. The first note to solve the puzzle and create that new valid block gets a reward of brand new coins. And the paper makes this fantastic analogy. It's just like gold miners spending resources to dig new gold out of the ground and put it into circulation. Here, it's CPU time and electricity being spent to secure the network and create new currency.
So when you put all of these pieces together, the public chain of ownership, the proof of work securing it, and the incentive to participate, you get this amazing new thing. A system that creates security and agreement without needing to trust a single person or company in it.
And this is the payoff. The math just works. The paper runs the numbers, and you can see that even for a really powerful attacker, the chance of successfully reversing a transaction just plummets with every new block that gets added. After just a little bit of time passes, the probability becomes so small, it's basically zero. The system gets more secure with every passing minute.
And that brings us to the paper's incredibly powerful and honestly humble conclusion. After laying out this entire elegant, world-changing system, Satoshi just states the fact. The goal was met. We now have a system for electronic transactions that doesn't rely on trust, a true breakthrough.
Now, the white paper was all about creating a peer-to-peer electronic cash system. But the ideas inside it, this decentralized ledger secured by proof of work, they cracked open a whole new universe of possibilities. And it leaves us with this huge question that people are still trying to answer today. If we can build money without having to trust anyone, what else can we build?